Swayam Prabha. Digital India. Educated India.
Okay. So, morning. Now, last class we have said that average power for a forced oscillation we have derived. That average power in case of forced oscillation is nothing but a F square, which is the applied force divided by Rm mechanical resistance divided by 2 mod of Zm square, which is mechanical impedance. Okay. And we said that average power will be maximum when Zm is minimum, and Zm is nothing but a Rm plus Jxm, and Zm will be minimum if Xm is equal to 0. Okay. If Xm is equal to 0. So, that means Zm is equal to Rm at Xm is equal to 0. When Xm will be equal to 0? The Xm will be 0 if the force frequency, if the force oscillation. So, the force frequency is equal to the natural resonance frequency of the system. Omega is equal to omega 0. So, if the natural resonance frequency of the system is omega 0 and if the applied force is the omega, the frequency is omega, then Xm will become 0, because we have done that last class. They proved that because that Xm is nothing but a omega m minus s by omega. We proved that at omega equal to omega 0, Xm is equal to 0. Okay. So, in that case the maximum power transfer will happen. Now, if omega is equal to omega 0, this has another name. If omega is equal to omega 0, then the maximum power is nothing but a F square by Rm into 2 Rm square. So, Rm square will be cancelled. So, F square by 2 Rm is the maximum power. Now, when the omega applied force frequency is equal to the natural resonance frequency, we said the mechanical resonance has happened. So, that phenomena is called mechanical resonance. Now, if you see, if I draw, so I said the mechanical resonance maximum power transfer will be happened at omega equal to omega 0. Now, if I draw the curve, maximum power transfer curve, if you see the curve in the PowerPoint, in the curve, if you see, if in the curve what is saying, that if I take a axis, this axis is omega, okay, and this axis is the power, then I said the maximum power will be happen at omega is equal to omega 0, maximum power transfer will be. So, less than omega 0, this kind of curve I will get. Okay. So, this is called mechanical, this is the power, mechanical resonance curve. Okay. So, mechanical resonance curve, different kind of resonance curve will be I will get. So, the maximum power is F square by 2 Rm. Now, how we define this slope of the curve? Who define? Which parameter define this slope of the curve? Okay. So, I have to find out those parameters which define the slope of the curve. Okay. Now, you know that from who have the electronics background, they know that if I have this kind of curve, if this is the maximum power, then 3 dB down, if the power expressed in dB, then 3 dB down we got half power frequency. This is called half power frequency. So, if this power is 1, this will be half, this will be half, that in dB it is 3 dB down. So, if the lower half power frequency is omega L and upper half power frequency is omega U, upper half power frequency, then we know the quality factors of this resonance curve. How steep is the resonance curve? is defined as omega 0 divided by omega u minus omega l. That is called quality factor. That means, if this bandwidth omega u minus omega l is the bandwidth, if bandwidth is very small, then the curve will be stiffer. If the bandwidth is very large, curve will be broader. So, that is the power transfer curve of the mechanical oscillator. Okay. So, the quality factor is defined on omega 0 divided by omega u minus omega l. Okay. Now, how do we get the value of this parameter, omega l and omega u? Now, think a mechanical systems, we said it is half power. So, if the power is maximum is 1, then it is power is half. So, what does the power, what is the power equation? Average power is f square by 2 Zm square into Rm. This is the power equation. Now, if this is the power equation, when it will be half? When the Zm is equal to, at Zm is equal to 2 Zm, the power, if it is twice, then the power will be half. If it is twice, then the power will be half. So, I said that if Zm is equal to 2 Rm, because the total power is f square by 2 Rm. So, this will be half when Zm is equal to 2 Rm. If you put that Zm is equal to 2 Rm, you get this expression is the half expression, half of this, half of the total power, because if it is nothing but a f square by Rm divided by 2 into 4 Rm square. So, the half power will be happen. So, if it is half power happen, then I said Zm square will be, sorry, Zm square will be 2 Rm square. So, if it is Zm square is equal to 2 Rm square, then I said pi is equal to f square by f square into Rm divided by 2 Zm square. So, I said f square by Rm into 2 into 2 Rm square. So, Rm cancel, it is 1 by 2 into f square by 2 Rm. So, this is half power happened. So, the condition is that if Zm square is equal to 2 Rm square, then the half power is happened. Okay, half power is happened. So, this is the condition that when half power will be happen when Zm square is equal to 2 R square. What is the Zm square? Is nothing but a Rm square plus Xm square. Nothing but a Zm square is equal to 2 Rm square. Okay. Now, then Xm square will be what? Plus minus will be 1 Rm square. So, Xm will be plus minus Rm. Okay. So, if Xm is plus minus Rm, then what is Xm? Reactance. Xm is nothing but a omega m minus s by omega is equal to plus minus Rm. Okay. So, plus minus Rm. So, I can say if it is Z value is plus minus Rm. So, Xm is plus Rm and Xm is equal to minus Rm. So, at upper frequency the value will be half high, lower frequency the value will be low. So, in that case the omega m minus s by omega, this omega is u, s by omega u is equal to plus Rm, and omega l m minus s by omega l equal to minus Rm. Okay. Now, if I substitute these two equations, the s, this is the equation number 1, equation number 2, just substitute the s, I get omega u minus omega l is equal to Rm by m. Rm by m. So, then quality factor is nothing but a omega 0 divided by Rm by m. So, the stiffness of the curve, how narrow is the curve, is defined by parameter Rm by m, mechanical resistance divided by the mass of the system. So, quality factor is nothing but a omega 0 divided by Rm by m. So, I can write it is omega 0 divided by 2 beta, because beta is equal to Rm by 2m. Okay. Similarly, 1 by beta is equal to tau, I can write half omega 0 tau. Okay. So, this is called mechanical resonance. Now, why it is required? Suppose I want to design this microphone. Okay. Now, if I operate a microphone at resonance frequency, what will happen? The diaphragm will be broken down. So, I have to design that oil below the resonance frequency, and I have to know what is the power transfer of the, at that point. So, I have to draw the power curve of that diaphragm. So, I have to know this, what is the quality factor of that power curve. So, I can easily calculate the quality factor of the power curve. So, that is why this theory has to be known. Okay. Now, I go for the another chapter, which is called mechanical to electrical conversion or equivalent circuits. It is not equal, it is equivalent circuits. Can I draw a equivalent electrical systems for a mechanical systems? Yes, it is possible. If I start with the simple oscillator, you know that, and mass, the simple oscillator mass and stiffness is S. What is the equation of motion? d2x by dt square plus Sx is equal to 0. Okay. Similarly, if I draw a simple LC circuits, there is a inductance and there is a capacitance. Simple L and C circuits. Okay. Now, if I say if the current is I flowing in these circuits, then what is the equation of the charge flow in these circuits? So, what is current? I is nothing but a charge per unit time. So, I can write dq by dt. Now, what is the electrical equation of these circuits? Total equation, it is nothing but a voltage across the L plus voltage across the C will be equal to 0. Voltage across the L and voltage across the C will be equal to 0. So, voltage across the L, what is the voltage across the L? L di dt plus voltage across the C 1 by C integration of I dt, that should be equal to 0. There is no external voltage source. So, that should be equal to 0. That is called Kirchhoff loop rule. Kirchhoff loop rule, you know that. So, inductance is, if there is no variation in the current, inductance across the voltage of the induction is 0. See, if there is a variation in the current, then there is only voltage across the inductance. Capacitance, it store the charges. So, it is I integration of I dt. Now, you just replace. What is I? dq dt. So, it is nothing but a L d2q by dt square, okay, plus 1 by C dq dt, integration over the dt. So, integration and differentiation will be cancelled. So, it is nothing but a q equal to 0. So, if you see this equation, equation number 2 and equation number 1, they are equivalent equation. M d2x by dt square plus Sx is equal to 0. Here L d2q by dt square plus 1 by Cq into 0. So, I can say the M mass is analogous to electrical inductance and capacity or stiffness of the spring is analogous to inverse of the electrical capacitance. Okay. So, mass is analogous to L and capacitance is inverse of that stiffness, or I can say C is 1 by S or S is 1 by C. Okay. So, any mechanical circuits if it is given, so this is a mechanical circuits, I can say the electrical equivalent circuit is this one. Now, if I add in the mechanical circuits mechanical damping, I just add a mechanical damping in here, which is Rn. Okay. Now, if this is Rm. Now, if I apply a voltage source F in here, okay, then the equation of motion, if the force is not there, then the total equation of motion is m d2x by dt square plus Rm into dx dt plus Sx is equal to 0, equation of the motion. Similarly, just add a resistance here, I add a resistance R in here, electrical resistance. Then what is the equation of this electrical circuits? It is nothing but a voltage across the L, which is L d2q by dt square, we have already proved, plus across the resistance R into I means dq dt plus 1 by C into q is equal to 0. Now, see, this equation and this equation are the identical equation, where m is again equal to L and Rm is equal to R and S is equal to 1 by C, equivalent to 1 by C, and X displacement in case of mechanical system is equivalent to charge in electrical system. Similarly, current in particle velocity in mechanical system is equal to nothing but a dx dt. So, this is equal to dq dt. So, it is nothing but a current. Now, if I apply a voltage source here, sinusoidal voltage source here, and here apply a sinusoidal force here. So, it is nothing but a sinusoidal voltage source. Let us V cos omega t, here it is F cos omega t. So, this is equal to F cos omega t and this is equal to V cos omega t. So, force here, mechanical force is nothing but a electrical voltage. So, equivalent electrical circuits for this mechanical circuit is this one. So, I can easily draw any given a mechanical circuits, I can easily draw its equivalent electrical circuits, and I know the equivalence of mass is equal to electrical inductance, equivalent of mechanical resistance, electrical resistance, equivalent to stiffness is inverse to the capacitance, X equivalence to Q is a charge, U equivalent to I current, and force is equivalent to voltage. Similarly, if I Z is nothing but a force by velocity, force by U. So, in case of electrical, impedance is nothing but a voltage by current, V by U, V by I. So, impedance is nothing, mechanical impedance is nothing but equivalent to electrical impedance. Okay. So, you know that. Now, cascading. Another point is that, okay, suppose I make two springs together, what will happen? Or I can replace one single spring by this kind of cascading, or I can replace this spring by a parallel cascading. So, these two kind of cascading I can do. Two kind of cascading I can do. One is called parallel cascading, another is called series cascading. Okay. Now, in case of series, so a force is applied on spring 1, let us say it is spring 2 S2 and this is spring 1. So, force is applied on spring x2, spring 2, and it is extended, displaced by x1, or sorry, x2, let us say it is x2. Okay. And S1 spring is displaced is x1. So, total displacement is nothing but a x1 plus x2. Okay. Now, what is x1? x1 is nothing but a force by string 1 stiffness, and x2 is nothing but a force by string 2 stiffness, x2. So, if I put that, it is nothing but a F by S1 plus F by S2, F by S1, F by S2. So, 1 by S1, 1 by S2. So, it is nothing but a 1 by F into 1 by S1 plus 1 by S2. Now, if I put in F into C1 equivalence, 1 by S1 means C1 and 1 by S2 means, so it is nothing but a C1 plus C2. So, when it will be C1, if the two C are in, when it will be, if I have two capacitance, one is C1 and another is C2, how it will be connected to get the equivalence capacitance, which is C1 plus C2. So, in that case, what I will get, if it is connected in parallel, what will happen? Let us say that the two C1 and C2 are connected in parallel. What is the equivalent capacitance? C effective is C1 plus C2, because impedance is C1 1 by C1, it 1 by C2. So, it will be 1 by C1 plus 1 by C2. Okay. So, effective will be C1 plus C2. So, in that case, this is equivalent to this one. So, I can say if the two springs are connected in a series, that means it is nothing but a two equivalent circuit will be two electrical capacitance connected in parallel. Okay. Similarly, if the two string connected in parallel, this is the one string and this is another string connected in parallel, this is S1, this is S2, force is applied F, then what will happen? In that case, let us, the F is applied and displacement is x, total displacement is x. Okay. So, the total force in acting here is force in here plus force in here. So, if it is F1 and if it is F2, so F is equal to nothing but a F1 plus F2. Now, what is F1? What is F1? Spring into displacement. So, it is nothing but a S1 x1 plus S2 x2. Okay. So, it is nothing but a S1 x1, sorry, displacement is x. So, x and x. So, it is nothing but a S1 plus S2. Displacement will be x. So, it is nothing but a S1 plus S2. Now, it is equivalent to 1 by C1 plus 1 by C2, because S is 1 by C. So, 1 by C1 plus 1 by C2. So, when will be the capacitance 1 by C1 plus 1 by C2? When they are connected in series. If it is C1 and C2, C effective is 1 by C1 plus 1 by C2. Okay. So, when they are connected in series. So, if the two springs are parallel, is equivalent circuit is two capacitance are in series, which is C1 and C2. Okay. So, I can draw easily for any mechanical circuits to its electrical equivalent circuits. Okay. So, if I have a mechanical circuits is like this, let us do some exercise for that. I have a mechanical circuits. So, there is a mass, spring constant S, mechanical resistance Rm, and the force is applied in here. What is equivalent electrical circuits? Always look for the U, total current in here, U. U is nothing but a current across the mass, you have to look about to, then draw the equivalent circuits. Okay. So, I can see one or two exercise from the book, and then I solve in here, so that you can easily conversion with that things. Okay. So, this is simple, which I have drawn, all are in series, all will be in series, resistance, capacitance, then inductance, then the voltage source. Okay. Now, instead of that, if I give you the circuits, mechanical circuit like that, let's M is in here and it is connected to a mechanical resistance and a spring S, Rm, M, and a force is applied in here. Force is applied in here. Then what is the equivalent electrical circuits? If I told you to draw the equivalent electrical circuits, so that means if the force is applied here, so velocity in here is u and velocity in here is um. If I pull this circuit, so velocity in here it is u and velocity is here in mass velocity, which the mass is acting on the velocity, the mass in motion, if the mass is motion, the motion of the mass is the particle velocity here. So, now if I say this is my force, this 2 point I apply this force F between these 2 points. So, here I will go for a current u, okay, particle velocity u, the current will flow like this way. So, which will be expressed to the u? S and Rm. So, what is S? Capacitance. What is Rm? Resistance. And I have another current is um here. So, u is what is u? M? Inductance. So, it is 1 by S, it is Rm, it is M. So, equivalent electrical circuits. Similarly, suppose I have in circuits, mechanical circuit like this, mass, spring, force is applied here. Similarly, I will say this is u and this is um. So, this is the force between the 2 point, force is applied here. So, who see the u current? This is the u current, spring see the u current, spring is nothing but a capacitance and um seen by the mass. So, this is m and this is 1 by s. Okay. Similarly, let us another example. Another example is like this. I have an ground, spring, okay. Then I have a mass m. This is S. This is S. This is M, and then I have a mechanical impedance, and I apply a force in here. Force is in here. So, if I see the two system, this is one system and this is another system. So, this will be u in here, u will be here, and this system let us um in here. Okay. So, I can again you write the force F, then this is the u will be here across the what? Resistance, draw. Then I get um in two circuits. So, there will be a capacitance and inductance L or M 1 by S Rm. Here is um is flowing. Okay. Because this side is grounded. So, these two is one combined together. Earlier we said mass is different because mass is not supported by the ground. Okay. This side it is 0 because this is the grounded. So, this total circuits is exposed to the current. So, it is and this is U. So, this way you can solve any mechanical circuits to its equivalent electrical circuits. Similarly, it is very easy to prove that the power, average power, total power in the mechanical oscillation, which is E, it is nothing but a potential energy plus kinetic energy, which is same expression will come with the current power, V into I, same expression will come. So, power will also will be the same. Okay.